We are going to start with example 1, where we will graph the ellipse, identify all the important information. So when you are graphing an ellipse, the first thing you want to do is get it into standard conic form. This equation is already in that form. When we mean standard conic form, we mean x squared and y squared on the same side of the equation and having that all set equal to 1. So we don't have to do any solving here. Now, something that we want to take note of is the center is going to be at 0, 0. Just like with parabolas and circles, the center is going to be very obvious when it's not at the origin. You're going to have a value inside the parentheses with an x or a y shifting that ellipse. We don't have that right now. We just have x squared and y squared. Then you want to identify what your major axis is, and your major axis goes along with that a value, and a is always larger. So this term right here is dealing with my major axis, so my major axis is going to be y. It's always helpful to figure out what your a and your b values are. So a is always larger than b. A squared is larger than b squared. So if a squared equals 49, then that means a is 7. And remember what a represents, the distance from your center to your vertices. And then we're going to have b squared is 16, which is going to tell us that b equals 4. When we're talking about distance, we really only care about that positive value. We will be moving in multiple directions, positive and negative, but you don't need to worry about writing plus or minus 7 for your a value. And then c is your foci, and c squared comes from the equation c squared equals a squared minus b squared. Now we wrote that down on the top of your notes just a few minutes ago. So if we want to figure out what that c value is, we can now plug in a squared and b squared. So c squared equals 49 for a squared minus 16 for b squared. So 49 minus 16 is going to be 33, which means C is about 5.7. So we can go ahead and just round to the nearest tenth here, because when we're graphing, it's going to be really difficult to differentiate between anything more than that anyway. So let's go ahead and graph. The center is at 0, 0, so we'll start with the center at the origin. Now my vertices are going to be 7 units away from my center. My major axis is y because the larger value is underneath that y. So I'm going to move 7 units in the y direction. So 7 units up. 1, 2, 3, 4, 5, 6, 7. Put a point there. That's one of my vertices. And then 7 units down. 1, 2, 3, 4, 5, 6, 7. And to find those vertices, we were starting from that center point. So those are my vertices. We want to find those ordered pairs. So they are y-intercepts. Those are going to be 0, 7, and 0, negative 7. Feel free to write 0 plus or minus 7 if you would like. Now we'll go ahead and do our co-vertices. Those go along with our b value, and our b value is 4. So we're going to move 4 units right and left in the x direction because the b is underneath the x. So from the origin, from the center of our ellipse, 4 units to the right, put a point. 1, 2, 3, 4 units to the left, put another point. So now I'm going to do my best to sketch this ellipse just like circles. It's not going to be pretty, and I even totally missed over here. I want to fix that. I missed again. Well, we'll deal with it. Okay, so there's my horrible ellipse. We can find these ordered pairs right here, and that's going to be at 4, 0 because it's an x-intercept, and negative 4, 0. Those are my ellipse. Co-vertices, sorry. So now we're going to go ahead and look and find our foci. Remember that our foci we found is 5.7. That is the C value. C always goes with foci. And we're going to keep in mind that the foci are on the same axis as your vertices. So from the center of my ellipse, I'm going to go up 5.7. Somewhere in there. And then down 5.7. And we're looking at somewhere. It's really hard to write on an iPad, guys. Somewhere down there. Okay. Writing the ordered pairs for our foci, those are going to be in the same format as our vertices because those are y-intercepts. So we can go ahead and say 0 plus or minus 5.7. So you're welcome to do that for all of them. You're welcome to write out the foci separately as well. All right, time to look at example B. Now notice that it is not in standard form. We do not have this set equal to 1. I can tell immediately that this is an ellipse though because the coefficients of x squared and y squared are different. If the coefficients were the same, that would be a circle. So I'm going to go ahead and get this set equal to 1, and I'm going to do that by dividing every single term by 100. And then when you do this, you're going to simplify the fraction. So we're going to simplify the 4 over 100 to become x squared over 25 plus the 25y squared over 100 will simplify to become y squared over 4. So the 25 over 100 is what's simplifying to become essentially 1/4. And then that's equal to 1. So now we've got this standard form. We can see that the center is going to be at 0, 0 because there are no parentheses with the x and the y. So there's no shifting happening. We want to make sure that we figure out what our a value is, our b value, our c value, and our major axis. So we'll start with our major axis, and we'll notice that the larger value, the a value, is underneath the x. So this is going to be x-axis, and then we can find our a, b, and c. So a squared equals 25, which means that a equals 5. B squared equals 4, which means that b equals 2. Remember that a is always larger. That's how I knew what a was. Now I want to go ahead and figure out what c is. So c squared equals a squared minus b squared. That's my foci formula. You're going to have to know that. So c squared equals 25 minus 4, which means c squared equals 21, which gives me c a value of about 4.6. So again, we're going to go ahead and just round to the nearest tenth. So now we're ready to graph. We have everything we need. My center is at 0, 0. My major axis is parallel to the x-axis, so I'm going to be moving in the x direction, whatever my a value is, which in this case is 5. So 1, 2, 3, 4, 5 units to the right. 1, 2, 3, 4, 5 units to the left. My b value is 2, so I'm going to go in the opposite direction. So 2 units up and 2 units down. And I'm going to really hope I can draw a better ellipse this time. Oh yeah, I missed a little bit, but that's better. All right, so now I've got my ellipse going on here. I can go ahead and write my ordered pairs for my vertices. Your vertices are always with the major axis. So here I've got 5, 0 to the right and negative 5, 0 for the left. You can notice that the x value was my a value, the major axis, so that's what's changing. The x value is 5 and negative 5. It's changing. The y value is staying the same as 0. And then my co-vertices, that's my b value, which was underneath my y. Those ordered pairs are going to be 0, 2 and 0, negative 2. We're just getting those from the graph. And again, you can see what's changing is the value in the y spot. Finish this up with finding the foci at 4.6. Your foci always lie on the same line as your major axis. So we're going to go 4.6 to the right, somewhere in there, and 4.6 to the left, somewhere in there, and write our ordered pairs. So we're looking at plus or minus 4.60. So again, with the foci, it's matching with the vertices. Those y coordinates are all the same at 0, and the x coordinate is what is changing.